In a previous video, I've shown a library I made handling the WinBond W25Q flash memories. That library includes functions allowing to develop an external loader for these devices, communicating via SPI. External loader is a software module that allows STM32 Cube Programmer package to program and read external flash memories, having them mapped on the STM32 microcontroller's address space. And as CubeIDE, while flashing projects into the microcontroller's memories, uses Cube Programmer modules, setting up an external loader simplifies the CubeIDE external memory setup with project data and programs. As we have seen, ST provides many information sources about the creation of external loaders. They mainly refer to flash memories communicated via quad SPI, parallel buses, or even oct SPI. These ports give a really fast data communication, allowing, for instance, to directly run programs from the external memory. Quad SPI, parallel buses, and so on are available on the higher microcontroller range of the STM32 family. And these microcontrollers normally have also rich features even in the other devices, for instance even in terms of the size of the internal RAM available. That is probably why the ST guidelines do not take so much in consideration the external loader RAM occupation. An external loader is loaded on the microcontroller RAM during the flash memory phase, and it needs about 40 KB of RAM or more available on the microcontroller. That RAM size, being normally not a problem in the higher STM32 range, can become an important limit for microcontrollers that could use a single SPI flash memory like the W25Q we are considering here. For instance, the known Blue Pill board mounting an F103 has a 20 KB RAM. It is too small to host an external loader created following the ST guidelines and examples. In this video we will see a new version of a library that, distancing from the canonical ST schemes, allows to generate a much smaller external loader, needing 12 KB of RAM or less, allowing its usage on a much wider range of the STM32 microcontrollers. As this external loader doesn't strictly follow the ST indication to develop it, I kept it in a separate GitHub repository. If you like to have a canonical external loader as per ST documentation and examples, you can refer to the repository I already shown in the previous videos. If you like to try to use this small footprint external loader, you can get the library available in the new repository. I will leave both links in the video description. Before proceeding, I just warn you, I will assume you already know flash memory technology and handling and how to develop external loaders. I've shown that in details in other videos of this series. If you haven't seen them, I strongly suggest you to watch that videos before proceeding here. You know that the linker aim, broadly said, is to link all the object files generated by the compiler together with the libraries in the single executable program. The default linker configuration makes it to discard, to remove all the functions available in the various object files, but never used, never called inside the program. This way, the linker minimizes the program size, keeping into it only the required functions, removing all the unused program parts. This action, performed by the linker, can be easily verified just generating a program, and then compiling it again after removing a function call not used elsewhere. Here is a project handling an ST7735 display. The main loop calls a function testing the graphic library performing drawings and writings on an SPI TFT display. You can find details about the display and the library in other videos of my YouTube channel, but details are not important here. we don't even need to run the program of the microcontroller. What I want to show you is just that compiling the program, we see its size. It is 35 kilobytes. And we can verify it contains all the library functions, the graphics ones, the SPI handling ones, and so on. And these functions are in the various source files of the project. Compiler generates the object files, one per each .c file, and the linker set up a single executable program. Okay, now I try to put a comment on the graphic test function call. It is the unique graphic function called in the program. I don't change anything else in the project. You see that the same test function is still available. Source and the header files are still in the project, and nothing was changed. Nothing else that the function call removed, commented in main. Now, compiling the project, we see we come to a much smaller executable file. And looking into its structure, we see that the program lacks the whole set of the graphic functions. Here are just the initializing ones, called before entering in the main loop. That is due to the linker action. Compiler generated object files for all the C files of the project, containing all the functions. Linker gets the object files and avoids to put in the final program the unused software parts, setting up a much smaller executable program. Now it needs less than 10 kilobytes, that just removing a function call. Let me repeat it again. Functions are still available in the source files. Compiler generated object files containing all the functions. Linker generated an executable file discarding all the unused parts. Removing the comment and enabling the function call, I go back to a program having a size of 35 kilobytes, containing all the graphic functions it needs to run the test. Back to our external loader project, we know that all the working functions are in the loader_src file. This function will be directly called by QProgrammer when it will need to access the external flash. The external loader main function is empty. There is no any function call. So, compiling the project, linker will discard any loader_src function, being them unused in main. That is why we need to go as per ST guidelines to the project options and into the linker options. We have to unselect the discard unused session parameter. We need to keep the loader functions even if never called inside the program. Removing that flag, we set the linker so to keep the unused function inside the executable program. And this way the linker will keep the external_src functions for the next usage. But it will keep also all the other functions inside the C files of the project. The unused functions of the microcontroller library, of the GPIO driver, and of the SPI1. Coming to the 40 kilobytes external loader we know. There is another way to force linker to keep functions into the executable file even if unused. We can specify the object file we want to keep in the linker script. Here, adding the request in the linker script text section. Specifying linker_src object file we will force linker to keep all the functions inside that file into the executable. This way, we can leave enabled the flag discard unused section. And all the unused SC, HEL, CMC's library functions will be discarded. The result will be a quite smaller executable file containing only the required software. So this is the first and the main changing in the new external loader configuration. Asking to keep the loaders_src object file in the linker script and keep instead the discard unused section flag in the project configuration. Using external loaders for SPI flash memories on QProgrammer, I've seen that the verify function is never used, never called. If you ask QProgrammer to verify memory content after flashing it, you can see that QProgrammer calls just the read function. It clearly will perform the written data verifying just using the microcontroller to read data, not using its verify function available in loader_src. I'm using the last version of QProgrammer available now, the 2.14, and I created external loaders for SPI flash memories on M4 cores microcontrollers and F411, on M3 cores and F103, and on M0 plus ones. I set up external loader for a G071. QProgrammer never calls the verify function. That is obviously the same for CubeIDE, as, how we have already seen, it uses QProgrammer package to flash memories. So, being not used, I remove, commenting it, the full verify function in loaders_src, further reducing the external loader size. The function is still available in the source files, under comment, in case a future version of QProgrammer will begin requiring it. Above the reading function of the external loader, it seems that it is run by QProgrammer under a sort of a timer control. And probably, as SPI communication is low, I mean slower than quad SPI or parallel buses, asking QProgrammer to read a large set of data, it returns an error. It seems it is something internal to QProgrammer, and it really seems it is due to a timeout, because the data you can read without error changes with the SPI port speed. Increasing the speed, we increase the datasets we can get in a single reading without errors. Anyway, even setting SPI port speed to a quite high value, about 50 megabits per second, we can't read more than about 1 megabyte of data in a single reading command. That's it. What this means in using QProgrammer. Keeping in mind that all I'm saying here is related to the single SPI flash memories, you can reliably use QProgrammer flashing memories even with a large set of data. But when you will go reading flash, consider that you have a limit in the data you can read without getting errors. This is an example. I'm using here an F103, a blue pill, with a W25Q64 flash on SPI1. It is an 8 megabyte flash. SPI port is set to 2 megabits per second. Opening QProgrammer, I start clearing the full flash memory. Now I get a test file on my PC. It is a 180 kilobyte file. It goes to 2D000. 180K. I'm going flashing it into memory. Note that I am not enabling verify feature. We will see it in a short. Writing completed. Going back to reading flash. Reading a small set of data, I get the memory content without problems. Increasing the data size to read, I directly move to 2F000, reading the whole written dataset. I get errors. You see, I get memory content up to about 7 kilobytes. Then I get an error. This doesn't mean that there is a problem on Flash. It is due to the limit of QProgrammer. If I go reading data starting from an upper address, you see I can get the flash memory content without errors. And I can see it is fully correctly programmed. You see? So, handling an SPI flash memory external loader on QProgrammer, there is a limit in the data size you can read. It is not a faulty flash, not an error on your external loader, it is QProgrammer. Now, combining the two facts about QProgrammer we have seen until now, we come to an easy conclusion. Enabling verify request flashing memories, we will get an error flashing large set of data. Here I go again clearing flash. Writing a small size file on flash and requesting to verify after writing, I get the flashing and the confirmation of a good writing. File is correctly written. Note that the memory contains dash signs. Now, asking to write a larger file, enabling verify, I will get an error. The error is on the verify stage. Reading content, I see the file is written. Note I use a plus sign in the larger file, and it is correctly written until the end of file. Now, taking a further step, we can easily understand that we cannot enable verify flag on CubeID using external loader for SPI flash memories. Okay? Again, it is not a problem of external loader you made, of your SPI memory, or of your microcontroller. It is a limit of QProgrammer, probably designed to work on faster memories and having these limits on the SPI flash memories, at least on the current QProgrammer version. We have seen in the previous videos that the checksum function uses a software algorithm to calculate the value it returns. Any STM32 has on board a CRC device that performs a CRC calculation based on standard algorithm. ST application note AN4187 describes in detail the CRC peripherals available on the STM32s. Here we can see that there are two versions of this device. Briefly said, we can say that there is a simpler device performing a single CRC algorithm with fixed configuration parameters, and a second programmable device on other microcontrollers performing computation over a range of algorithms, data size, and configuration parameters. I changed the checksum function so to use the CRC device in the simpler configuration, so it should be able to run on any STM32. CRC device can perform a really fast computation, not involving CPU, being able to work autonomously using DMA to access memory. In the checksum function, I paid attention to the RAM occupation, using the smallest buffer size possible, 4 bytes. That makes the verify function slower, but getting to a smaller footprint external loader. Using CRC device, it has to be enabled in CubeMX during the microcontroller configuration. I applied other optimization here and there, as for instance completing the configuration of the struct in devins.c that now doesn't anymore generate a warning message when compiled. The result of all of these changes is an external loader that needs about 12 KB of RAM available on the microcontroller. The size changed a little with the microcontroller used. So now you can set up an external loader even on a smaller STM32, like for instance a Blue Pill board. External loaders make really easy setting up a project having an external flash memory involved in storing data and programs. Now, for sure, you cannot use an SPI flash memory as an expansion of a microcontroller internal flash to run programs. But if you want to show on an SPI display handled by a Blue Pill the picture of your girlfriend, or if you, like me, have to show the picture of your wife, and obviously the same is for boyfriends and for husbands. If you have to handle pictures or other large dataset on flash memories, now you can easily do it even using the smaller STM32s, even using a Blue Pill. But how to do it, how to set up this kind of project on CubeID using an external loader is the topic of the next video. See you there. Thank you for watching. Ciao.